Energy and motion are found in common everyday things we find around us. Energy is a capacity for doing work. Motion is a term we use to describe things moving from one place to another. I can illustrate energy and its transformation using this ball. I put work in by raising it up to this height above my head, and then it transforms into energy of motion as I let go of it. Now we'll go over to our propulsion test facility and meet with engineering student Melanie Janetka.
What we do here is test small-scale versions of rocket engines to see how the real ones will behave in flight. That's the whole idea behind proportionality, and doing it this way makes space transportation safer, more affordable, and more reliable. By taking his bike on a test run, Van was able to see how his bike would perform in an actual race. Proportionality is the use of ratios. In other words, this engine is about 2,000 times smaller than the real thing. Van's test run was 25 times shorter than the distance he'll travel in the race. Proportionality is used for everything. That includes art, cooking, and architecture.
When we are designing and constructing state-of-the-art, multi-million-dollar stadiums, there are several steps we must take even before ground can be broken. One of those steps is to build the stadium, but on a much smaller scale. We call this proportionality. It's the use of ratios like 1 to 100 and scales in order to meet challenges. It's nothing new. It's likely the Egyptians used this to help build the Great Pyramids and the Romans to help construct the Colosseum. Today, proportionality is used everywhere. NASA even uses this to help construct future spacecraft. This is a scale model of the Raymond James Stadium, home of the Tampa Bay Buccaneers. Every inch here equals 100 feet, or 1,200 inches of the real thing. A lot of this goes back to math class. It's all about proportions and scaling things. We pay close attention to the relationship between sizes.